Hi everyone. In this video, I'm gonna go over two examples with you, and in this video, I'll also show you guys how to use your TI-84 to solve questions that involve binomial distributions. Okay, so most of the time, I'm not saying that always, but most of the time, questions involving binomial distribution, you will be allowed to use a calculator. So in other words, you'll see them in the calculator paper, okay, paper 2, okay, but not always, okay, not always. So it's always good to know how to do this algebraically without a calculator, and using a calculator, so different ways. Okay, so let's get started. This is example 4 from your textbook. So please pause the video and try to understand the context of the problem here. Okay, welcome back. Now, so here they already told us that it is binomially distributed, and then we have 6 trials. My n is equal to 6. Okay, success is 1/5, so my p is equal to 1 over 5, and then they want us to find the following probabilities. So we can write this: my x is binomially distributed. Make sure you write this down. You have to put this down. Okay, this will count as one of the points for your workings. All right, so this is what we have for now. So let's look at A. Exactly 4 successes. All right, so my random variable x represents the number of successes. So right now, my p of x is equal to 4. Is simply equal to, my n is 6. My r in this case is 4. Probability of success is 1 over 5. So let me write that down. 1 over 5 to the power of r. My r is equal to 4. And the probability of failure is 1 minus 1 over 5. So that's 4 over 5. 4 over 5 to the power of n. N is 6 minus 4. So that's 2. So then you can just put that in your calculator. You can use the NCR. Let me bring my calculator. So on your calculator, there are 2 ways. Right? There are 2 ways of using this. So you can go to your math, go to your probability, and then go to NCR, go to 3. And you'll see that. So 6C4 multiplied by 1 over 5. Oh, sorry about that. Multiplied by 1 over 5, 1, 5 to the power of 4. And then multiplied by 4 over 5. This is 4 over 5 multiplied by, to the power of 2. Hit enter, you get 48 over 3125. 48 over 3125. Which is approximately, how much is that in decimal places? Let's see. Change that to decimals. Approximately 0.1536. 0.1536. 1536. Okay, so that's my answer for part A. Now, if they want you to round it up to 3 significant figures, make sure you do that. Okay. Now for part B, actually before we do part B, there is another way. There's another way to compute this, to find the exact same thing, by using binopdf. So you go to, let me just do that again. You click on second bars. That will bring you to distribution. Right? So second bars. And then you just scroll down. You'll find binopdf. Binopdf is here. Trials We have 6 trials. P is 1 over 5. So you can choose 1 divided by 5. My x, in this case, I want 4. And that's it. And that will give you the same thing, 0.01536. So there are 2 ways of doing this. Now, when you guys are showing workings, this is what you need to show, okay? Let me just do that in red. This is what you need to show. If you are allowed to use a calculator, you don't even have to do this. You can just simply put this down as the answer. Okay? But if it's in the non-calculator paper, make sure you show the workings here. Okay? Okay. Let's do part B and part C. Now for part B, at least 1 success. So another way of saying that is, what is the probability? At least 1. So which means 1 is okay. But we want anything that is bigger than or equal to 1. So we're trying to find that. Another way of saying this will say, well, all of my probabilities has to add up to 1. And I want everything but this. So the only thing that doesn't match is this. Right? The only thing that doesn't match is something that is less than 1. In other words, it is the 1 minus 1 is 1 as in the whole probability, 100%, minus when my x is equal to 0. Does that make sense? I hope it does. Okay? So this probability here, we can sort of manipulate it using our inequality and sort of our logic as well. But now what I have to do is I'm just going to use the binopdf to find this. Okay, I'm just going to use binopdf to find that probability. So let me move my calculator to this side. So this will be equal to 1 minus, so I just use this will be the workings for a calculator paper. All you have to do is to write that down, and that will count as your workings. Okay, so now we just do binopdf. I'm just going to go up, copy that statement, and now instead of 4, I'm looking at 0, so just change the 4 to 0, hit enter, and you will have 0. I think it was 262144. And 1 minus that gives us 1 minus my answer, 0.7378. Now let's round it up to 3 significant figures. I have 0.738. Approximately. Okay? We need a little bit of analysis here. Just a little bit. Okay, just a little bit. Well, so be careful with the inequality sign, because we're talking about discrete. That's why we can do this. Right? We're talking about discrete random variables, so this makes sense. Now, let's do part C. 3 or fewer successes. So this is a bit harder. Let me just label them. This is my A. This is my B. Now let's do C. This is 3 or fewer successes. So probability of 3 or fewer. So it can be 3 or less than that. So this means I will have probability of x is equal to 0 plus probability of x equals to 1 plus probability of x is equal to 2 and plus probability of x equals to 3. Right? Now, there are 2 ways of doing this. You can use your binopdf. Use your binopdf for all of them, and then just kind of add them up. There is another way. So I'll leave this method to you guys. You guys can solve it using the binopdf and find the individual probability and just add them up. And your answer should be 0. somewhere around 0.983. Okay? So I'll leave that up to you guys. Use binopdf, find the individual probability, and just add them up. You should get to 3SF 0.983. Now, there is another way. And I'm going to show that to you guys. It is called the binocdf. Binocdf. Okay? Now, the C represents cumulative. Cumulative. Which means I'm going to add them up. I'll add. I'm going to add everything until where I tell the calculator to stop. So let's take a look at what I'm talking about. So bring up your calculator and let's go to second bars. Just scroll down and we will see binocdf. Click on that. The trials, it is still 6. The P, this is 1/5. Now the X value, be careful with the X value. When we are doing binocdf, whatever X you have here, that is also included. So in this case, we're trying to find the probability of 0 plus, we're trying to find the probability of 0, 1, 2, 3. Right? So we're doing everything starting from 0 all the way up to 3. So that's why we have 3. And then just click on enter, paste, and that will give us, as you can see here, 0.983. However, if let's say today they're asking us to find X is less than 3, what do you think? What changes am I going to make to the binocdf? The entries that I put in my binocdf, what's going to be different? So everything P is the probability of X equals 0, plus 1, plus 2. I won't have this. This is not going to be there now. So for the calculator, I'll have to change the 3 to 2. And that will be the sum of these probabilities. Okay, so I hope you guys see the difference of binopdf and binocdf. It is very, very important to know the difference. And I need you guys to know when do we use binopdf, when do we use binocdf. Binopdf, we're talking about the individual probabilities. Binocdf, we're talking about a cumulative probability. Okay, now make sure you share this calculator skill, right? The binopdf, binocdf. Share these calculator skills with your friends who are not watching this or who did not watch this, because by knowing these skills, it really helps us speed up the calculation process. I don't have time for the next example. In the next example, I will show this to you guys, and I'll save that for the next video. Alright, for now, this is it. I'll see you guys. Bye-bye.